Throughout our limiting reactants lab, our main goal was to understand mole ratios of limiting reactants. We used multiple test tubes and certain amounts of potassium hydroxide and copper sulfate. After adding water and mixing it, we came upon the revelation of the supernatant. The test tube that had the perfect amount of reactants according to the ratio formed by balancing the equation was test tube 5. It had twice the amount of copper sulfate than potassium hydroxide.
Previously, we have learned that chemical equations must be balanced. They have to be balanced because of the law of conservation of mass. The law of conservation of mass states that mass cannot be destroyed by a chemical reaction or a physical transformation. We can predict the amount of reactants and products in a chemical equation because of the mole ratio. A mole ratio is determined by the coefficients in the balanced chemical equation. Those balanced equations inform us about the amount of products. Before starting the lab, we were informed that reactants do not always form the amount specified by the equation. After our lab was completed, we concluded that the balanced form of the chemical equation was as follows. CuSO4 plus 2KOH is equal to K2SO4 plus CuOH2. We learned that a liquid forms above the precipitate called the supernatant. Accordingly, some of the reactants have an excess. Therefore, the reaction continues to play out until one is used up. Throughout the lab, our purpose was to observe the reaction between potassium hydroxide and copper sulfate in different mole ratios, then measure the precipitate in order to find the limiting reactant of each test tube.
The materials we used were 0.2 molarity of potassium hydroxide, 0.1 molarity of copper sulfate, a burette, 8 test tubes, water, a spatula, and a beaker. We fill the burette with the right amount of potassium hydroxide and copper sulfate. Second, you label all the test tubes. Third, you write a balanced equation with the reactants that you have. Fourth, you put 5 milliliters of copper sulfate in all 8 test tubes. Fifth, you add potassium hydroxide to the 8 test tubes according to what amount the chart is telling you. Then, you add water to the 8 test tubes in order to have filled up each of the test tubes up to 13 milliliters. Finally, we waited 15 minutes and measured the precipitate.
The result from the lab showed that the precipitate levels off on test tubes 5, 6, 7, and 8. This is because there is no more copper sulfate to react with and make more precipitate. Consequently, there is potassium hydroxide supernatant left over above the precipitate. Some errors that could have occurred while following the procedures was not being able to take accurate measurements of the precipitate and adding too much or too little amounts of potassium hydroxide or copper sulfate and water when needed to make sure all of the beakers were the same. Some suggestions for improvement are that we can use a burette to measure the water more accurately.